The first step in solving this problem is calculating the capacity and flow rate for the system. Capacity is defined as the number of resources over the activity time, and let's add it to the table. In this instance, for resource 1, capacity would be 2 workers over 10-minute processing time. For resource 2, 1 over 6, and for resource 3, 3 over 16. Right now, each of these capacities are given in units per minute. You could convert them to units per hour by multiplying them each by 60 minutes, but for now, I'll solve the problem in terms of minutes. In any case, the process capacity is equal to the resource with the lowest capacity, which in this case is resource 2, at a capacity of 1/6 of a unit per minute. Thus the cycle time is also equal to 6 minutes. The formula to determine the time for a certain number of units through an empty system is the sum of the activity times through the empty system plus 1 less than the total number of units divided by the flow rate. In this instance, that is equal to the sum of the 3 activity times, or 10 plus 6 plus 16, plus the total number of units being produced, 100, less 1, all over 1/6. If you solve that out, it's equal to 626 minutes, or 10 hours and 26 minutes. For part B, we've already calculated the average labor content, which is equal to the sum of the activity times, or 10 plus 6 plus 16 is equal to 32 minutes. For part C, to calculate the average labor utilization, we first must determine the idle time per worker. This is equal to the cycle time times the number of workers minus the activity time per worker. So, for resource 1, this is equal to 2 times 6, which is the cycle time, minus 10, which is the activity time, or 2 minutes of idle time. For resource 2, which is the bottleneck, we know that there must be 0 idle time. And for resource 3, we have 3 workers times 6 minutes cycle time minus 16 minutes of activity time for 2 minutes of idle time. Altogether, that means we have 4 minutes of idle time. Now, to calculate the average labor utilization, we must take the labor content of 32 minutes and divide it by the labor content plus the idle time of 4 minutes. That is equal to an average labor utilization of 89%. Finally, for part D, to calculate the cost of direct labor, we must first account for the total wages per unit of time, and then divide that by the flow rate per unit of time. In this instance, we have 6 workers who are each making $10 an hour. We can then divide that by the flow rate, which we've said is 1/6 units per minute. But because we have the wage in dollars per hour, let's convert that to hours by multiplying times 60. Solving that equation, we get a final cost of direct labor of $6 per unit.